Hi, in this video, I make a beginner tutorial for 3D scanning using the CR Scan Raptor, and the object that I will scan today is this Dremel. I will use the scan result for making 3D illustration of the model, and also I will make cutting shield by using the scan result from the scanner. Actually, what you see here is not a video, it's a 3D render of what I'm going to scan in this video today. I show you how I make this cutting shield of the Dremel that I designed by not using CAD software, so you can do it very easy from scanning to design without using CAD, and then you can send this model directly to the printer for printing. Creality Scan that you can download from the website. On the left is the project list of the scan that you have made. When you click on a new project, it will create a folder that contains a scan or multiple scans. You can scan one object with several scans, and then you can merge them together. So each project, for example this one, this project has 3 scans from different scanners, so you can put each scan into the same project. This is a beginner guide, so I will start with making a new project. I name the project Dremel Shield. Next, you come into the configuration page. You have 2 tabs, blue laser mode and infrared mode. Raptor has 2 projectors. One is the blue laser and the second one is the infrared. Mainly the Raptor is made for blue laser. It gives sharper details and higher definition, and today we're going to do a reverse engineering. So I use the blue laser. In this tab you find that it has real-time resolution. The value can be varied from 0.1 to 2 millimeter. The width of the laser line of the Raptor is 0.1 millimeter wide, so the minimum resolution that you can get from the scanner is 0.1 millimeter, which means that for 1 square millimeter you will get a 100 points of the point cloud. So if you put 0.5 in 1 square millimeter, you will get 9 dots of the point cloud. 100 dots per square millimeter, 9 dots per square millimeter, 25 dots per square millimeter. This slider, you need to decide what kind of detail you expect to get from your scan model. If you are scanning a coin which has a very small detail, I would probably go for 0.1 millimeter, and for a Dremel this size I would go for 0.2, and if you are scanning a car panel I would go for 0.5, and if I want to scan a whole car I will go for 1 or 1.2 millimeter. When you first making the scan, the color of the point cloud will turn from orange to green when it has enough information to build 0.1 millimeter resolution. So if you use larger resolution, it will turn green quicker, so you can scan faster. Okay, I hope that you understand this information. So real-time resolution is important. You need to decide in advance what kind of resolution that you want to get from the scan. Next tab is the color mapping. I already made this in my previous video. There's a small RGB camera that will capture the color of the model. You don't need this for reverse engineering. The color mapping is for illustration. It doesn't do a very good job because the RGB camera is lower of the resolution. I click no for this. Usually I would never use it. Exclude flat base. It means that when you put your object on a turntable which is flat, if you click yes, it's supposed to exclude the base of your scan, so you don't have to delete it later. But this version of the software, there is an issue with the Raptor, and the Raptor X is work fine with the other, so I suggest that you click no for now. The scanner comes with this look like a mouse pad, and they give you some sample marker. There's a 6 millimeter and a 3 millimeter. For the Raptor, the effective distance between the marker is 5 or 6 centimeters, so you need to space the markers randomly. When you click on start the scan, if a scanner won't see any marker, it will not show up on the screen. As soon as you put the marker on, So you can start to make your first scan. Click on play button here and it will start scanning. This is just an example, so I will press on this button. Look like a paintbrush. Actually, it's a clear button, so you can clear the scan if you don't want the scan that you made. So if I want to scan this cutting blade from the Dremel, just put it here. One thing, there's an exposure tabs on the left. Make sure it's automatic because the default value is manual and I find that it's too dim. The automatic exposure works 90% of the time. You should change that before you start scanning. Okay, let's do one more sample. See, when you do the first scan, there is a range. It's telling you the range here in this tab. It should be somewhere around optimum and good, and you can see it here from the lighting. If it turns green and it's in an optimal position, and if it turns orange or red, it means that you are too close. You need to back off just a little bit. And if it's in blue or light blue, it means that you are too far because we need to move around the object and the object is round. So let me put it this way. We are not actually applying the markers onto the object. The scanner tracks the external marker on this mouse pad. If your object moves during the scan, it will fail. The object has to be static. Even a small vibration will make the scan lose its sharpness. So to make it a little bit more easier, I suggest that you get a turntable. This is an airbrush painter turntable, and this way you can easily turn the object without moving it because this object is very small. So I will scan with the resolution 0.1. You can exit the scan here. There's a small plus sign on the upper right corner. You click exit the scan and then you can change the resolution to 0.1. Now I make a scan. Click on the automatic exposure. Okay, let's stop the scan and review the result in the PC. This is a raw scan file, it's not processed. Next, you need to delete the base of the scan. So click on the lasso selection tool, hold on Shift key and select the object that you want to keep. If you hit a delete key, this thing will gone, but that's not what you want. Choose inward selection. So now the table is selected. Hit delete key and the table is gone. Now you need to delete the base of the scan. Next, you need to map the point cloud. There's a button here, optimization setting, because we scan with the 0.1 millimeter. So I click 0.1. And marker removal, if you actually attach the marker into the object, you should click this checkbox. It will remove the marker sticker from the object. So our first scan is incomplete. The back side of the cutting blade is not scanned. You need to figure out a way to orient the object so that you can scan all the sides and make a full close match. So I will put 3mm markers. I put 4 of them. Actually you need only 3, but I recommend you to put at least 4. I put it onto this side 2, and I put another 2, a little bit space further away, 3. And 4. So I make a first scan by scanning all around the object in this direction, and then I flip it over and make a second scan, and then I use these 4 markers for merging reference. The original mouse pad doesn't work anymore, it's not good. I use this external marker. I put the download link in the description. It will help you to scan object much easier. Put 6 here. One thing to note that during the scan, none of the external marker can be moved. If you move it just a bit, then you need to restart the scan. I tried with the global marker. Actually, this object is very small. It doesn't make any difference. Global marker is to scan the location of all the markers here. And it tells you the number of the marker that is scanned. So we have 147 markers. It shows on the upper right of the screen. Pause the scan and then you click on the point cloud and it says complete global marker scan. Yes, optimize the marker. So now the marker is optimized and you can start the scan of the point cloud. So now we have already complete scanning on this side, but the bottom side here won't be scanned. So I need to flip it 180 degrees to scan the other side. And then I put it. Now we can move to process the point cloud and merging. So now we have two new scans. I rename it blade 1 and this one I rename it blade 2. Okay, so let's start with the blade 1. Actually it looked the same but different orientation. Selecting the blade, the inward selection, process the point cloud at 0.1 millimeter. Sensitivity, I don't know what that is until now. Nobody can answer that. When I slide it up and down, it doesn't make any difference, so just leave it like that. Probably they add that to make it look more like a professional software, but it doesn't do anything actually. Scanning is like pointing a flashlight into the object. It's going to cast a shadow. So here's your shadow. It won't capture the surface under the shadow. Let's move to the second one. Using a 0.1 millimeter resolution. Alright, let's merge them. Click on the point cloud merging icon on the right here, and then we merge with the manual merging. Click on the marker merging. Click on blade 1 and blade 2. See here, we have 4 markers that we put on. So you just click on the first pair. Hold shift key and click on the marker. It's turned red because it's the same pair. Second pair and third pair. Actually you need only 3 and then start button will emerge here. But we have 4, so I click 4. You can have a maximum of 5 pairs. Click on the start buttons. See here, it's already merged. Click yes and then exit. Okay, now after merging, the file name changed to the component 1. You can't unmerge it and then it will go back to the original scan before merging. Next I will mesh it. If you look at the upper right corner here, we get 621,000 point clouds. This is the approximate number that you can create a triangle mesh. So when you choose the mesh setting, you should choose the faces number to match the points of the scan data. So this one I choose somewhere around 67,000. If you choose to mesh with too many faces, you won't get any more detail. It's just the interpolation between the points, so it won't benefit you anything. Click on hole fitting. If there is a small hole there, it will fill it. Because the software that we're going to export to has a closure feature, so I don't need to close it now. But even though the model look close to me, all the dimension is close. Look pretty nice for a very small object. So I make 2 scans in the horizontal position. I scan it like this and then I flip it over, scan another side. So I put 3 mm markers, maybe 4 or 5 along the sides of the Dremel so that it will be visible on both scans. So I put it closer to the seam line of the plastic here so that it will be visible in both scans. So we have 5 markers should be enough for the alignment. So I add some clay to support the object and put it here. Okay, it shouldn't be moving. I choose the resolution 0.2. I click on start the scan. I click on automatic exposure. Click on global marker. It's all done, and then we move to the other side, which is here, this side. What is the clay? So it won't be moving. I move to the second scan, 0.2, automatic exposure, global marker. We'll click on the point cloud, want more complete global marker scan, yes. Let's next process the point cloud and merge it. I process the point cloud 0.2 millimeter. Okay, so some leftover. I need to delete it. Optimize the point cloud using 0.2 millimeter resolution. I will merge them. Dremel 1 and Dremel 2. Go to merge screen. Manual merging, marker merging, Dremel 1 and Dremel 2. So you need to turn it 1, 1, 2, 2, 3, 3, 4, 4, 5. Okay, start. So okay now. Complete the model. Click yes. Exit merging. So in this video, we're going to make a shield for a Dremel machine. I will mount the cutting shield onto this thread. There's two ways to do it. One is that I scan the female thread and then I create an extended model out of it to make a shield. But scanning the female thread is very difficult for optical scanner because you can't scan both sides of the threads. It's deep inside the hole. So if I scan this side and then I scan this side, this lid will block the light from seeing the other side of the thread, so it's very difficult to scan the female thread, but it's easier to scan the male thread. I add the markers onto this surface and then I scan it all around. I choose 0.1. I need the highest resolution because I'm going to cut this thread into the clay. Okay, let's use 0.1 millimeter. So we have the thread. Look nice. I use closure so it will close all the sides. Okay, so we have the mesh to make a female thread of the shield. Next, I will export these 3 models and then the thread export obj. So we have finished our scan and export all the models. There is no other reason for you to be here anymore. You need to close the Creality Scan software and move forward with your favorite software for 3D modeling and cleaning. In this video, I will choose the Adobe Substance. This software is very easy to use. If you go into Steam and you search for Substance, there are 3 Substance software here. Actually, this one, the modeler, is around $80. The painter is around $100, and it's easier, much easier to use than ZBrush and the Blender. There is very minimum interface that you need to remember. You can use it for sculpting and some hard surface modeling also you can. Okay, let's move to the software and then I show you how easy it is to work with your scan in Substance 3D Modeler.